Hello students, welcome to my YouTube channel Learn and Travel with Shuchishmita. In the previous video, we finished question number 5 and in this video, we will solve from question number 6. Now let's start the decimal representation of rational number. In this video, we discuss about decimal representation of rational numbers. So let's start. What is decimal number? Decimal number. Decimal number are divided into two parts. One is terminating and another is non-terminating decimal. So first one is terminating decimal and second one is non-terminating decimal. Non-terminating decimal. So first, what is terminating decimal? Terminating decimal. If the division is exact and no remainder is left, okay, the quotient of such division is called terminating decimal. So if division is exact and no remainder is left, the quotient of such division is called terminating decimal. Terminating decimal. Okay. So now let's take an example. 25 by 4. We divided 25 by 4. 4 6 jam 24. No one is bring down here. Now we take a point in the quotient. So here we take 0. Now 4 2 jam 8. We bring down 2. Then for point we get 0. Now 4 5 ja 20. So the quotient is 6.25. Here you see this division is exact and no remainder is left here. So such type of quotient is called terminating decimal. The quotient of such division is called terminating decimal. And what is non-terminating decimal? Now non-terminating decimal. Non-terminating decimal is of two types. First one is recurring decimal. And second one is non-recurring decimal. show recurring decimal. See an example, 1/3. Here 1 divided by 3. First we take in quotient point. Okay, now we get 0. Now 3 is a 9. Subtract 10 with 9. Then we bring down 1. Now for point we get 0. Now 3 is a 9. Also we bring down 1. So here 0. Now 3 is a 9. And this is repeated. 0.333 is repeated, dot so on. Okay, so here you see the recurring decimal, one digit or a set of digit is repeated. Okay, this is called recurring decimal. Here a single digit is repeated, 3 is repeated here, so we are put above dot or bar above this number, this single digit, dot or bar. Okay, so we are put above 3 dot or bar. Okay, now another example is 1/7. So this is 0.147325, 147325. This set 147325, this set of digits here repeated, so we put the bar on the set of these digits. Okay, so here bar will be on the set of each digits. Okay, so this is called recurring decimal. Okay, if one digit or the set of digits are repeated, this is called recurring decimal. Now what is non-recurring decimal? Non-recurring decimal see an example, √2. √2 is 1.414215, so on. Division is going on, so no single digit or set of digit is repeated here. Okay, this is called non-recurring decimal. So what is non-terminating decimal? Non-terminating decimal is if division never ends. Okay, this is called non-terminating decimal. If division never ends, this is called non-terminating decimal. In terminating decimal, the division is exact, no remainder is left. But in non-terminating decimal, division never ends, division is going on. Okay, now what is pi? Pi means circumference of circle by diameter of circle, and the pi is in decimal number. The value of pi is 3.14159 and so on. Okay, the value of pi is never repeated. Okay, now we have to know, without any division, any actual division, find the rational number is terminating or not. Actual division, find the rational number is terminating or not. Okay, so now how to prove without any actual division the rational number is terminating or not. So how to prove? Okay, first, if the denominator of rational number can be expressed as 2 to the power m into 5 to the power n, where m and n are whole number, the rational number is converted into terminating decimal. The rational number is converted into terminating decimal. Okay, so if the denominator of rational number, suppose let's take an example, 17 by 50. Here the denominator is 50. Okay, so if we expressed the denominator as 2 to the power 5 into 5 to the power n, where m and n are whole number, so this rational number is converted into terminating decimal. Okay, otherwise this rational number will be non-terminating decimal. So 50, now we factorization 50. So the factor of 50 is 2, 2 is 4, 2 5 is 10, 5 5 is 25. So we expressed 50 2 to the power 1 into 5 square. Okay, so we can express 50, as 2 to the power m into 5 to the power n, where m and n are whole number. Okay, so this 17 by 50 is terminating decimal. Okay, so here see this definition. If the denominator of rational number can be expressed as 2 to the power m into 5 to the power n, where m and n are whole number, so this rational number is called terminating decimal. Okay, now question number 6, exercise 1a. Here we will solve from question number 6. So question number 6, see the question number 6. Without doing any actual division, find which of the following rational number have terminating decimal representation. Okay, now we apply this process. Okay, so first question is here 7 by 16. Now here denominator is 16, so the factor of 16 is 2 8 ja 16, 2 4 ja 8, 2 2 ja, so we can write 2 to the power 4 into 5 to the power 0. Okay, there is no term of 5, so we can write 5 to the power 0 means this is 1. 5 to the power 0 is 1. So we can express solo as we can express 16 as 2 to the power m into 5 to the power n. Okay, so hence 7 by 16 is terminating decimal. Now question number 2, 23 by 125. Here denominator 125 and 5 2 ja 10, 5 5 ja 25, 5 5 ja, so 5q into 2 to the power 0. So 125 can be expressed as 2 to the power m into 5 to the power n. Okay, hence 23 by 125 is terminating decimal. Now question number 3, 9 by 14. So the factors of 14 are 2 7 ja 14, 2 7 ja 14. So 7 cannot be factorization here, so we can express 2 to the power 1 into 7 to the power 1. So 14 cannot expressed as 2 to the power m into 5 to the power n. Here 7 to the power 1, so we cannot express 14 as 2 to the power m into 5 to the power n. So 9 by 14 is not terminating decimal. Okay, terminating decimal. Now question number 4, 32 by 45. Now you have to factorization of 45. Okay, so 5 9s are 45, 3 3s are 9, so 5 to the power 1 into 3 square. So we can't express 45 can't expressed as 2 to the power m into 5 to the power n. Here see 3 to the power 3 square, so we can't express 2 to the power m, so hence 32 by 45 is not terminating decimal. Okay, now question number 5. Question number 5 is 43 by 50. Here 50, 2 2 ja 4 2 5 ja 10, 5 5 ja, so 2 into 5 square. So here 50 can be expressed as 2 to the power m into 5 to the power n. So 43 by 50 is terminating decimal. Question number 6 is similar. So now we will solve question number 7. 61 by 75. So the factors of 75, 5 1 is 5, 5 5 is 25, 5 3 is, so 5 square into 3. So 75 cannot be expressed as 2 to the power m into 5 to the power n. Okay, so 61 by 75 is not terminating decimal. Now question number 8. 123 by 150. 2 7 is 14, 2 5 is 10, 5 1 is 5, 5 5 is 25, 5 3 is 15. So 2 into 5 square into 3. Okay, so here we can express 150. We cannot be expressed 150 as 2 to the power m into 5 to the power n. Okay, we cannot be expressed 150 as 2 to the power m into 5 to the power n. Here also you see 3, so we can't be expressed 150 as 2 to the power m into 5 to the power n. Hence 123 by 150 is not terminating decimal. Okay, now question number 7. Represent as a decimal number. So first question is 4 by 15. Okay, now 4 divided by 15. So here 4 is less than 15. So now we will take point in the quotient. Now we have 0. So 15 2s are 30. Now we subtract 30 from 40. So we bring down 10. For point we take 0 here. So 15 6 are 90. We bring down 0. Now we take 0. Okay, so 15 6 are 90. Now we have 10, and for point we take 0 here, and also 6 the 15 is 90. So this division is going on, and the single digit 6 is repeated here. So the quotient is 0.2666. So we can write it 0.26 dot. Okay, now question number 2. 2 by 7. Now we divide it to 2 by 7. So here 2 is lesser than 7. So here we take point on the quotient and we have here 0. So 7 2s are 14. Now we have 6. So 6 is lesser than 7. So for point we have 0. Now 7 8s are 56. Now we have 4 and here 0. 7 5s are 35. Now 5 and here 0. Now 7 7s are 49. Here I have 1 and for point here will be 0. So 7 1s are 7. 3 now 4s are 7 4s are 28. Here also have 2 0. 7 2s are 14. So here you see this set of digits is repeated here. Okay, so the answer is 0.285714. This set of digit repeated here. Okay, now 285 will be repeated. These digits will be repeated. Okay, so question number 3, 4 by 9. So here point 436. Now 4 for point here will be 0. Now 9 4s are 36. Also this will be repeated. 4 9 4s are 36. Here 4. So the single digit is here repeated. So the quotient is 0.4 dot. Okay, now question number 4, 5 divided by 24. So 24. So 5 is here lesser than 24. Now we take point in the quotient. So we have here 0. So 24 2s are 48. 2 and for point there will be 0. And also you see here 20 is lesser than 24. So we will take 0 in the quotient. So here will be 0. Now 24 8s are 192. Now this is 8 and 8 is lesser than 24. So here will be 0 for point. So 24 3s are 72. Here will be 8. Also take 0. Now 24 3s are 72. Here 8 will be 3 will be repeated here. Okay, so the quotient is 0.2083 dot. Okay, now question number 5, 8 by 13. 8 by 13. Okay, So 8 divided by 13. Now 8 is lesser than 13, so here will be point in the question, so here 0. Now 13 6 the 78. Here subtract 78 from 80, so we will have 2. Here 0. 13 1 is 13. 13 times 1 is 13. Now 7 0 and 5. 13 5 ja 65. 0. 13 3 ja 39. 1 11 is bring down. Here for point, here will be 0. Now 13 8 ja 104. 6 is bring down, so here 0. Now 4. 13 4 ja 52. So 8. Now this is repeated. Okay, here is 8, so here we will get 8. We got 8, so this term is repeated. This set of digits are repeated, so the quotient is 61538 bar. Okay, now question number 8. Express each of the following as a rational number that is in the form a by b, where a b belongs to z and b not equals to 0. Okay. So express each of the following as a rational number. See question number 8. 4 by, question number 1, 4 by, sorry, not 4, sorry, question number 8, 0.53 dot. Okay, express each of the following as a rational number in the form of a by b, where a b belongs to z, means that is a b is rational number and b not equals to 0. Okay. So here you see, first we write 53 all digits. Okay, for the recurring decimal, the rational number we can express in this process. So first we write all the digits, then the number which has no bar. Okay, so that is 5. Then subtract. Okay, and in denominator the term, the digit here has the dot or bar. So for dot and bar digits we write 9. Okay, and if the digit which has no bar, so this is 0. Okay, so this is 53 minus 5 is 48 by 90. Okay, now question number 2, 0.227 bar. So here you see, first we can write 227 is digits. Okay, now there is no digits after decimal with dot and bar. So the in numerator we have 2 to 7, and for denominator after decimal in the each digits there is bar. So for bar we can write here in denominator 999. Okay, now question number 3. Question number 3 is 0.2104. So here first we write 2104 is digits. Okay, then we write here only these digits which has no bar. Okay, so that is 2. Then we subtract 2104 and 2. Now in denominator for the bar we write 999, and the digit which has no bar we write 0. Okay, here only one digit 2 that has no bar, so we write for this digit 0. So now we subtract 2 from 2104, so you will get 2102 by 9990. Okay, now question number 4. 3.52 dot. So first we write 352 all digits, then we write here 35. Okay, the digits which has no bar we write here, then subtract, and now in denominator we have 9 for the digit which has bar, and after decimal there is only one digit which has no bar, so for this digit 5 we write 0. Okay, now we subtract, so we will get 317 by 90. Okay, so we can divide 317 by 90. Sorry, 93 will be 274. So 347 upon 90. This is the answer. Okay, now question number 5. 2.24689. So first we write 224689 all digits, then subtract 224. Okay, so the now digits which has no bar. Okay, now in denominator for the digits which has bar we can write 999, and after decimal here two digits 2 and 4 which has no bar, so for these two digits we can write 0 and 0. Now we subtract here, so we will get 22445 by 99900. Then we simplify this term, so 5 4 ja 20, 5 4 ja 20, 5 8 ja 40, 5 9 is 45, 5 3 is 15. This is also 5 1 is 9 is 5 9 is 8 0. So the rational number is 44893 by 19980. Okay, now question number 6. 0.572. So 572 you can write is digits here. Okay, 572, and there is no digit without bar, so we can write 572, and in denominator will be 999, the digit which has bar. Okay, so for the digits which has bar we can write 999. Okay, now question number 7. 0.158 dot 158, the each digits we can write here. Now we can write 15, the digits which has no bar. Okay, then subtract, and in denominator for the digit which has bar, so 8, for 8 we write 9, and after decimal here have two digits 1 and 5, there is no bar, so we write 0 0. Now we subtract, then we will get 341 by 900. Now question number 8. 0.0384 bar. So first we write 384 minus 3. Okay, the digit which has no bar, so 3. Okay, we can't write here 0. Okay, only 3. Now in denominator there will be 99, and after decimal the here has two digits 0 and 3 which has no bar, so for these two digits we write 0 0. So this is 381 by 9900. Now question number 9. Find the decimal representation of 1/7 and 2/7. Reduce from the decimal representation of 1/7 without actual calculation the decimal representation of 3/7, 4/7, 5/7 and 6/7. So first we have to find the decimal representation of 1/7. So now we will division here. Okay, so 1 is divided by 7, so 1 is here lesser than 7, so we take point in the quotient, so here will be 0. Now 7 1 is 7. Okay, so here we get 3, so for point we take 0. Now 7 4 is 28, so here we'll have 2, and 0 7 2 is 14, here we'll have 6 0, for point there will be 0. Now 7 8 is 56, subtracting we will get 4, then 0 7 5 is 35. Now we have 5, and for point there will be 0. Now 7 7s are 49. Here we'll have 1. So you see here 1 is repeated, so the answer is 0.142857 bar. Okay, then 142857 will be repeated and repeated again and again, so the quotient is 142857 bar. Okay, now here you see 2 by 7, the decimal representation of 2 by 7. You see, you can write 2 by 7 as 2 into 1 by 7. Okay, so we already got 1 by 7 is 0.142857. So we can write here 0.142857 bar. Okay, now we multiply 2 with this term, so we will get 417,582 0 point bar. Okay, now see, without actual calculation, the decimal representation of 3 by 7, 4 by 7, so deduce from the decimal representation of 1 by 7. So from 1 by 7, this decimal representation we have to calculate the decimal representation of 3 by 7. So we can write 3 into 1 by 7. So we know 1 by 7 is 0.142857 bar. Now we multiply 3 with this term, so we will get here 175,824.0 bar. Okay, now 4 by 7 is similar, 4 into 1 by 7, so 4 into 0.142857 bar, so this is 824175 bar. Okay, so similar for 5 by 7 and 6 by 7. 5 by 7 is 1 by 7 into 5, so 0.14287 into 5. Okay, so we will get this term 5824170 bar. Okay, now 6 by 7 is similar than 5 by 7, as like 5 by 7, 4 by 7 and 3 by 7 also. Okay, so now we finished